Welcome to another edition of Design Spark Ask the Expert. Today we're going to be talking about sustainability and energy management, energy efficiency. I have Stefan from Siemens with us today. Hi Stefan, do you want to say hello to Design Spark?
Hello, good afternoon to everybody. My name is Steffen Händler. I am at Siemens, responsible for the business development of industrial energy management. And today I'm going to answer the question of Greg and hope to can show you also some nice solutions regarding energy efficiency and energy management.
So let's get on to sustainability first, Stefan. We're talking about the two big topics, obviously sustainability, energy management, energy efficiency. Energy costs are rising. Sustainability with ESG agendas is very important on everybody's lips at the moment. So it's things that people are talking about. So, from Siemens' aspect, what is it you guys are actually doing around ESG, for example?
Siemens has a ESG program. It's called Degree, so there's also a little bit the greenhouse effect included. Actually, it's a 360-degree view on our priorities. Most important right now with most of our efforts is the decarbonization. So we want to sell our products with as less influence on environmental as possible. How it's done, I will show later some examples. But also ethics, governance, where does, for example, our raw material come from? Resource efficiency, was it produced economical or not, with a small footprint. It's also something we take care about right now regarding how to um, create such a footprint. We have a new product which we offer to our customer where he can use, for example, blockchain technology to track and trace the carbon footprint of all his raw material till the final product is in the supermarket, for example. Equity and employability. We have a lot of training programs, for example, for our employees to take care about the future requirements to us and to make us fit for it.
So there's a lot of kind of great points in there. So I'm just going to come on to with those points in mind. How does that actually help technician design better and more sustainable products?
Um, we track and trace any kind of energy involved in our products. We improve it also in the procurement. So to change, for example, from the fossil energy to renewables, or to use wind, or even better, to avoid the megawatts consumed inside of our plants. Just an example about the progress in the past years. So it starts here at fiscal year 19, and right now we targeting for fiscal year 25 a reduction of 55% of the carbon emissions. And finally, to zero carbon emission, the target is 2035. And it looks like that we are on a good track.
Yeah, that does look like those principles that you're employing are really paying off, and so that's really great to see in terms of ESG. I think we can all say that it's on the top of everybody's agenda, but to see the real hard fact there, as you showed me, I really do appreciate that, and that's a very strong, powerful message of the environment that you striving towards and working within. I just want to then touch about if we're moving to energy management, for example, then what is it that Siemens can do to support the end customer? Energy costs are rising. It's important that we make sure that we're being efficient with the energy. We don't want to add costs. And I'm just asking, what are the first steps towards energy efficiency?
The first steps is transparency. So if I don't know how my consumption looks like, how my energy flows are inside of my company, I don't have a chance to control and to manage them at all. So this is the major part to create transparency. Not only electricity, it's also steam, cooling, any kind of energy you can imagine. to take care of and to um, check if the usage of these energies is reasonable or not.
Right. And just if we expand on that slightly, what would be the kind of first steps that a user would take to, if they were on the journey to start to talk about energy efficiency and they wanted to get it up and running? What are those kind of first steps that they need to look at?
A really good approach is described, for example, in the ISO 50001. This is the norm for energy management inside of companies. So if you stick to the ISO 50001, you're on a really good track. You get, for example, tools and a systematic approach how to take care about the energy consumption and how to improve it. ISO 50,001 doesn't mean it's a piece of software. Actually, it's a complete process which is described inside of the ISO. And here we have somebody who is responsible to do something to improve energy consumption. We have targets he has to hit. We have for sure, hopefully, also a budget, but we also have hard and software helping the energy manager to achieve his targets. So here we need the measurement in the plant, we need the data acquisition, we need the data evaluation and presentation to get a clue or intelligence out of the data. Actually, it's not just a monitoring system in this case. You have a system which enables you to analyze your data much easier, and it's not a data grave. So you put intelligence to your data to make them much easier to interpret and to get a clue out of it.
In terms of the applications that you can have for obviously energy efficiency, you can range from the small. It could be a small standalone environment, or it could be a large industrial production site, for example. So, in terms of the scale, what is it you need to maybe consider in terms of the selection of the products, the sensors, and the size of everything? Are there any approaches that Siemens can help with on that aspect?
Yeah, actually, we have concepts starting with a single machine. So a lot of our machine builders are now also taking care about energy efficiency inside of a machine. Here we are offering energy meter, for example, built into automation, but up to corporate solutions, which is covering multiple sites, up to 50 plants which are connected to our systems. That's completely scalable. There's no actually limit in this point.
So, in terms of a lot of the processes that are measured using energy efficiency or energy management systems, what can you tell me about those parameters? So, for example, a lot of people will be thinking in current and volts, for example. They'll be looking at the power. But what about other media, for example, in terms of energy efficiency, like heating facility? We're talking about compressors for compressed air, pneumatic.
Yeah. Also for other energies like the compressed air, like cooling, which is, for example, very important in the food and beverage industry. We have metering devices. Partly they're already inside of automation, for example, used for loop control purposes. Um, if this is the case, we can offer a very easy interfacing of these devices to an overlaying energy management system. Perhaps I will just give an example how something like that can look alike. So I will share my screen again. So what we can see here actually is a running energy management system for food and beverage industry. Actually, if you're interested in that example, it's also available in the internet. We can post later a link for it. Yeah, what can we see here? Actually, it's a corporate solution, so it's really the biggest possible solution. We have multiple sites connected to our system, and perhaps you see here energy management. Where are the megawatt hours or the volts and amps that Greg just mentioned? Actually, we're not of interest at this level. we are here on a management view, and I'm more interested, for example, in the total cost of all my sites, or I'm more interested, a little bit more specific, how much did I produce with my cost, with my money. If I'm participating in the carbon dioxide emissions, I'm not interested in the tonnage because this is just a figure. I'm more interested in how is my actual emission compared to the budget I got inside of my company. So this is very important because at the end of the year, perhaps if I'm above my budget, I have to buy additional certificates, which will cost me a lot of money. On the right side, a little bit more detailed here now, the breakdown to my different sites. Actually, this is already a possibility to create KPIs, to create benchmarks. If I've got a possibility to compare two different sites with each other one. So if one is using significantly more energy for the same amount of product, for sure, this is a first indicator for me to take care about it, to have a deeper look into it. Yeah, let's have a deeper look, for example, into my site of Berlin. I can also go into my map widget and see in my tooltip text some details, but let's have a closer look to it. Let's jump into the detailed view of my site. And here you got now more information. Important is what I can see here. Not only the consumption is displayed, but also my production figure. So how many hectoliter of soft drink did I produce in my site here? And I can see that my production is following quite close my cost and of my consumption. So this looks already good. But if I need a little bit more insight, I can do an ad hoc analysis. So like it's indicated here. So let's just correlate electricity consumption with my production. And here I can see immediately, according to the position to the red line, if I had a good day, batch, hour, shift, whatever, or a bad one. So if I'm below the red line, it's indicating, okay, I produced more with less cost. So this is a good sign. If I have any problems, I need more details. So what you can see here actually is my plant, my total consumption of my site. Now I can jump into my departments, for example, like the water purification, the filling station, or my utilities like the steam and the compressed air production. Yeah. Let's have a look into my compressor station. Okay, so here I got compressor station with two compressors. Let's assume they're identical. And again, I don't see any megawatt hours. Why? I'm more interested how was my compressed air produced. So the specific energy consumption is more of relevance. For sure, I can also put megawatt hours to it, but it's easier to analyze it as we will see here if it's a specific energy consumption. And here, perhaps I can see immediately that compressor 1 is using less energy than compressor 2. So the difference here is around about 25%. Compressor 2 is consuming more, specifically per cubic meter than compressor 1. It's for sure something of interest. Let's have a look into the details. So here I can see on my right side, it's the daily evaluation of my energy compressed air production. That compressor 1, indicated by the yellow bar, is running more or less all the time. So it looks like it's used as a baseload compressor, while compressor 2, that's the red bar, is only switched on at peak times. So it's only used for the peak load. And this can already be an explanation for the higher specific consumption of compressor 2, because if it's ramping up and down all the time, for sure the efficiency will suffer from it. Actually, compressed air is energy, so I take not only care about how the energy was produced, I take also care about how the energy is consumed inside of my blood. Actually, compressed air in soft drink companies is mostly used for the production of bottles. So the blow molder, which is producing the plastic bottle, needs compressed air. And this means the compressed air consumption should follow quite close to my soft drink, to my soda production. If you have 100 liter of Coca-Cola, I need 100 bottles. Okay, so again, to my consumption of my compressed air, I got the production figures here. And yes, as we can see, they are real like a blanket for my consumed air consumption, so it looks already good. But I can also see one abnormality here. If I have a blow up of it, I can see here I don't have any production, so 0 hectoliters, but I still have compressed air consumption. So this is a typical indicator, for example, for leakages inside of a compressed air grid. Okay, as a maintenance guy, I know leakages are all the time present. It's a plug, but now I can put a figure behind it. How much does it cost? And this is very important because now I got a chance to uh, have the optimal answer for my problem. For example, to do a retrofit or to call preventive maintenance to take care about this problem.
That's really important to understand. Is that you know, we talk about condition monitoring and preventative maintenance, for example. But if we're looking here, we can see the real hard data from the facility and understand that there could be a problem here that's maybe not been picked up already. But you know, you're getting real time information, and you can identify that there could be a potential image here, a potential problem here with this uh, uh, compressor, for example, and then you can do corrective maintenance to fix that. So this is really important, to show that we're not just talking about looking at the energy, we're also looking at the profitability as
Yeah.
well as the efficiency of the installation through this data.
Actually, this is quite an interesting aspect. For sure, energy efficiency, saving costs for energy is a very important part. I can show another example where another feature of the plant comes into the game. Actually, if you have a look into a complex machine, let's take, for example, a chiller. Chiller is a very complex aggregate to analyze. We have a lot of thermodynamics in, we have dependencies of our outside temperature, of the evaporator temperature, which are influencing the efficiency of our chiller. So you can imagine it's a nightmare for an energy manager to analyze a cooling plant. To make it easier, we invented a trick. We invented a digital twin, or let's call it an energetic twin for our chiller. Just an example, you have the influencing factors like the evaporator temperature, the condenser temperature, even the part load has an influence. And now we take all these values from the past and generate a model out of it. And this model is now fed with the same values our real chiller outside in the plant is facing. So get the same temperatures, for example. And now the system is calculating a value, a consumption as it should be. So this is the green line we can see here. And compared to this, we see the magenta colored one. That's the value as it's measured. In the middle, you can see here is a gap, is a deviation between the two values. So actually here I got losses because my real machine is consuming more energy than my model is indicating to me. Actually, this procedure is called baseline management, and it's also described in the ISO 50001. The interesting part here is, out of these complex figures, I now create just at the end only one number, one figure, and this is how much deviation do I have to my set point, to my specification for my machine. But it's going even further. Again, I not only know that there's a problem inside of a machine, I can also see how much losses this causes and what is my cost for these losses over the actual week, for example. Yeah, and again, here I got how many euro I have spent due to the problem into my machine additionally. And this gives me also a good clue about, for example, to call a preventive maintenance to take care about this problem. But it has also another aspect. Actually, we go here now into the performance management, because if I can see an additional consumption, this can be caused, for example, by an internal fault, a problem, a worn out part, missing um, refrigerant, for example, which can cause a total breakdown of my system. And if I see it coming, I got a chance to react and not be surprised if my system breaks down at the most unwelcome time you can imagine. So now we're leaving even a little bit that energy efficiency part. Now we go into the performance management. We can increase the availability of a plant by monitoring its specific energy consumption.
Great. That's fantastic, showing us that level of detail. It really does put things into perspective for users. Because one of the things I was going to ask about is what trends are you seeing? So, for example, one of the things that we're seeing are, people are talking about, particularly when we're talking about energy and energy management, they can do the energy monitoring, but it's what's the next step to get into the energy management. And what you've shown us today really does show not just the data, but you're showing us the correlation between equipment cost and profitability using this type of setup. So I really do appreciate your time today taking us through this. It's been really enlightening for me for a start, for sure. um, Stefan, before we finish, I just want to know, do you have any closing statements you'd like to make? Is there any additional information you'd like to share with us about sustainability and energy management, energy efficiency from Siemens?
Yeah, just do it. You will be surprised how much money can be saved. So 10 to 20% is not unusual or even more,
Yeah,
but it has to be done. It's saving won't come from alone.
great. Stefan, thanks for your time today. I really do appreciate it. And I hope we can talk again soon on Design Spark.
You're welcome.